Stan Gibilisco here, showing my most recent iteration of a desktop background, a space station in orbit around a planet that looks a lot like Earth but has two moons. Where that planet may be, who knows? But it is a really cool looking picture, don't you think? What I'd like to explain here is the geometry of an electromagnetic field, the way that the electric, magnetic, and direction of propagation all relate to one another. Electric flux lines are the solid lines here, which appear to be running vertically. The magnetic flux lines are the dashed lines here, which run perpendicular to the electric flux lines. They don't look that way here only because it's a perspective drawing. But let's just imagine for a moment that these electric flux lines run up and down, straight up and down. The magnetic flux lines run straight north and south. And the reason that they're straight is because we are so far away from the source of the electromagnetic field that the lines look straight over the area that we're considering, say 100 meters square. They're actually form a very, very tiny parcel on a huge sphere, but that parcel is so tiny and the sphere is so huge that for all intents and purposes we can consider those lines straight. Once again, the electric flux lines running straight up and down, the magnetic flux lines running straight north and south, and the direction in which the electromagnetic field resulting from these flux lines travels is straight. Let's just suppose that this is east towards the right here. So north would be far, far away off of that away. Up would be far, far away up of that away. And east just goes along like that. An electromagnetic field comprises electric flux lines and magnetic flux lines perpendicular to each other, and the direction in which the resulting field travels is perpendicular to the plane containing them both. Sort of like a three-dimensional Cartesian coordinate system, where we might think of the x-axis as the direction of propagation, the y-axis as the magnetic flux lines, and the z-axis running parallel to the electric flux lines. Just a little bit of a relation little lesson in geometry, three-dimensional geometry, where you can have up to three straight lines that intersect at a common point, in this case right here in the center of the matrix. And they're all perpendicular to the other two. This one is perpendicular to both of these, and each one of these is perpendicular to the other two. So that is how they all relate in an electromagnetic field. Just the geometrical aspect of it, so you can kind of imagine in your brain what that's like. As for imagining what it's like to be on this space station or on this space vessel so far in the future around a planet as exotic as this, I've never done such a thing. But some people have been in the space shuttle, although this one would presumably be a lot more sophisticated and a lot more comfortable. Just an interesting little great images in NASA, aside to the main topic of this video. I always like to throw something in there that's off topic. Kind of dilutes the potion, don't you think? Stan Gibilisco signing off for now. Until next time, so long.